Hello everyone. Today we'll talk about stacks. This will be the first video in a series of videos that I will be making on data structures, in which we will talk about stacks, queues, linked lists, and binary trees also. So the first video in this is the stacks. This will be two videos, in which the first video, which is this video, will be the explanation of a stack and the whole behavior of a stack, how we will implement it in programming. And the next video will be implementation of stack in Java, and also solving a problem which can give very good results if we use a stack to solve it. So let's start with this video. In this video, we'll just be explaining what a stack is. And to know what a stack is, we have to see this image. This is the image of a game you may have played when you were a toddler. This is a game of stack a ring. Now, in this game, there were rings which were of different sizes, and you would have to put all these rings in the decreasing order of their sizes. This was a very interesting game which gives us a good idea of size and shape when you're very small, but this has an inherent behavior of stacks. Now, when we talk about stacks, we always talk about the LIFO system, or the last in first out system. This is a behavior which is the stacks follows, and this game stack a ring also follows the same behavior. You would receive this game just as it is in the image, completely stacked the object. Now you would have to put all these rings, you would have to get all these rings out of the game and then put it back again. If you think about it closely, when you put these rings, you put the biggest first, the biggest ring first, the second biggest, the third biggest, and then it goes up until you're left with no rings when you put this ball on the top. Okay, and then when you take the rings out, when you want to play the game again, you take this ball out first, then the ring, then the first ring, the second, the third, the fourth, and then goes down until it goes to the last ring, which is the bottommost ring. If you think about it closely, this is the whole idea of a LIFO, which means last in first out. What it means is the last element to go in a stack is the first element to go out. In this case, the last element to go in is this ball. And when we take out rings, we have to take this ball out first and then go and proceed to the next rings. If you think about it in another way, in a completely opposite way, the first element to go in the stack is the bottommost ring. But when you take out the rings, the last element to go out is the bottommost ring. So the last element to go in goes out first. First element to go in goes out at the last. This is the whole idea of a stack. Now, let's talk about how to implement this in an array or in a programming. Now, when you're programming, you need to put many elements together. And then a data structure, which we all have learned about, is the arrays, which actually keeps all the things together in one. So to make a stack in a programming language, you need to create an array, and you also need a variable called the top variable, which will point to the position which has an empty space, but it should be the bottommost position which has an empty space. That means it always points to the bottom when there is nothing in the stack. When there is something in the stack, it always points to the second place. So it will always point to the bottommost position, which is empty. If it is filled up to this position, then the bottommost position, which is empty, is this. So the top will point to this position. And this is how it works. So in this case, we can just use an int variable top, which will store the position which is empty. So it will store the number, the index number of the position. So let's say when the stack is empty, it will store 0. And whenever we need to add something to the stack, we will have to add it at the top position. That means whatever positions this top stores, we have to put that element in that position in the array, and then the top will increment to the next position. So at this point, the top has 0, and if we want to put something in it, we push a data. Let's say we push the number 10 into the stack. This 10 element will go to the 0th position, because if this is the indexing of the array, the 10 element will go to the 0th position, because at this point the top is 0. Then the top will increment so that it stores 1, because the next empty space is the 1 place. Now, if we have 10 here and we want to put another object into the stack, let's say we are pushing 20. Can you guess which position this 20 goes to? If you guessed this position, then you're right, because the top points to the 1th position, which is here. And so any element that you want to get into the stack, you'll have to put it at the top position. And remember, after putting an element in the top position, the top will also increment to, it means here. But now if you want to remove an element from the stack, what will we do? To remove an element, we just have to decrement the top. Now you have to remember that the stack is valid only below the top. That means all the elements that are below the top position are the elements that are in the stack. Even if some element may be there in the array, it still may not be there in the stack if this top element, if this top variable points to a different position which is below that position. So let's say if there are many numbers here, let's say there are these numbers, and the top is pointing to, just a minute, if say the top is pointing to this position, then the stack is only valid up till 40 element. So it will not take the 50 or the 60 element, because both these elements are either at the top position or above it. So there can be no element in the top position or above it in the stack. It still may be in the array, but the stack does not contain it. The stack is only valid up to the top. Pop function is very simple. In the pop function, we just need to decrement the top variable. In the push function also takes a value. We need to put v at top and increment top variable. But there is another method or another function that we can make, which is the peek method. Peek method shows you which element is there in the top, in below the top position. So if say this is 0, 1, 2, 3, 4, 5, 6, then any object which is here, let's say it's 20, 10, the top is pointing to here. Peek gives you this 20. That means any object which is there just below the top will be returned by the peek function. So it will return the element at the top of stack. Now, this alternatively also returns the first element which will get removed from the stack if we do a pop operation. As we know, the pop operation always removes the topmost element, and peek returns you the topmost element. Basically, the whatever peek returns at any point in the stack is basically the first element that will go out of the stack if a pop operation is operated. Now, this is the whole idea of all the functions that we need to make. There is push, there is pop, and there is peek. These are some names which are given to these methods, and these are some conventional names. You may make your own methods with your own names, but these are taken as standards. So in the next video, we will talk about how to implement it actually in a coding language like Java, and I'll also be giving you the implementation and the solution to the problem that we will be solving in C++ and Python also. So stay tuned for the next video. Thank you for this one. Thank you, everyone.